Okay, time for the second example of simplification and re-expansion, and I promise this time there will be some re-expansion. Notice here that in this circuit diagram we're given a circuit with 4 resistors and a voltage source, and the fact that there's a voltage source is going to make the problem a little bit harder than when it was a current source. We're asked to find the voltage V1, and we're asked to find the current I sub x. Now notice that V1 is listed as at a particular node, and so therefore that means that it is relative to the ground node. So the ground node, as is tradition but not required, is along the bottom of the circuit. That means that if I'm looking at where V1 is between the node that is labeled V1 and the bottom node, which is equivalent to saying that it's right here as well. So I can have it be just across the 3 ohm resistor. So I'm going to go ahead and redraw that V1 is across the 3 ohm resistor. It's completely equivalent. It's just that, you know, when things get more complicated, it can sometimes be a little bit easier to think of it that way. Now I need to simplify the circuit, and this first step of simplification seems to be that the 3 ohm and the 6 ohm resistor are going to be combined in parallel. So I'm going to go ahead and combine the 3 ohm and the 6 ohm in parallel. I'll just make a note up here. Here's a nice little shorthand notation for a parallel combination. It's not 3 divided by 6, it's 3//6. That's a symbol for 3 in parallel with 6 is equal to 3 times 6 over 3 plus 6. That's 18 divided by 9, which is 2 ohms. So that's a new notation that we haven't introduced anywhere before this. So I'm going to go ahead and redraw the circuit. Sometimes you can get away with doing a couple of revisions before you redraw the circuit, but I am a big believer in taking the extra time to redraw the circuit an extra time, because I think that it makes it a lot simpler to keep track of the changes that you've made. So here you can see that I've labeled the 2 ohm resistor, which is the parallel combination of those 2 resistors. I've got the 5 ohm resistor right here. I have the 4 ohm resistor right here. I can keep the ground node, although it's not essential anymore. And I've got the 10 volt source over here. Now the question is, can I continue to label V1 or I sub x in the circuit? Well, I cannot label I sub x because it was part of 6 ohm resistor and the 6 ohm resistor is gone. But V1 was the voltage across both of the 3 ohm and the 6 ohm resistor. Remember that because they're in parallel, they have the same voltage. I could also label V1 as being across the 6 ohm resistor. Since it was across both the 3 and the 6, I can go ahead and label it as being across the parallel combination of the 3 and the 6. So I've simplified the circuit a little bit. Time to simplify it a little bit more. I'm going to combine the 5 and the 2 in series. That's going to give me a 7 ohm resistor. So I have the voltage source, I have the 4 ohm resistor, and now I have the 7 ohm resistor. So this is the 7 ohm resistor. This is the 4 ohm resistor, ground connection, 10 volt source, and there's the simplified version of the circuit. Can I include V1 in the third version of the circuit? No, because it was only across the 2 ohm resistor. 2 ohm resistor is no longer present, so therefore V1 has gone dark. It's no longer visible, so we have to just move on. I've got one more version of the circuit that I'm going to draw. 4 in parallel with 7 is 28 divided by 11, and 28 divided by 11 in my notes, 28 divided by 11 is 2.545 ohms. So I can redraw one last version of the circuit. I didn't leave myself enough room here at the bottom, but I think you'll get the idea. 2.545 ohms, and that's 10 volts, and there's the ground connection just barely off the bottom of the page. Now, a little trick that I like to do, because we've now completed the simplification phase, and I kind of think of the process, and I'm going to sort of draw it over here on the left. I think of the process as like an hourglass, that we start by simplifying, but once we've simplified the circuit and we get a key answer, now it's time to re-expand. You could think of it as a tree trunk or an hourglass or whatever it is that you like to think of it as. But we've reached the bottom of the circuit. And now that we've reached the bottom, we're going to work our way back up again. Now, what I like to do when I'm solving problems is I like to change the color so that I know what I wrote the first time and what I wrote the second time when I passed my way back up the circuit. So you might not think that that's very helpful, and that's okay. You can choose to do it however you want. I'm going to switch colors so that I know when I've reached the bottom and when I'm working my way back up. So I'm going to label a new current. Now I can call this current whatever I want to. I'm going to go ahead and call it I1. I1 wasn't used in the original circuit. We were asked to find a current labeled I sub x. As long as I don't call it I sub x, I can call it anything that I want. I'm going to call it I1. And I can calculate I1. I1 is 10 volts divided by 2.545 ohms. And that works out to be 3.929 amps. Whoops. 3.929 amps. Okay, I1, by the way, is also in this circuit diagram. So that's I1. And now I can use current division to split I1 into two different currents. Now, I could label these currents however I wanted to. In this case, I think I only really need the right-hand branch. So I'm going to label this current as being I2. And then I can calculate I2 by current division. I2 is equal to I1 times the opposite branch's resistor, 4, divided by the sum of the two resistances, 4 plus 7. And I2 then works out to be 1.429 amps. 1.429 amps. Now I can move up again. I have I1 is here. And then I2, where is I2? Well, I2 is the current that flows through the 7 ohm resistor. Well, up here now, that's really the whole right-hand branch. It's the 5 ohm resistor. So there's I2, and it's this resistor, I2, and it's also over here. That's I2. So I can actually calculate V1 now because I know the current flowing through this resistor and I know its resistance. So V1 is equal to I2 times 2 ohms. V1 therefore is 1.429 amps times 2 ohms, and this works out to be 2.858. 2.858 volts. That was one of the two quantities that we were asked to find. All that remains now is to find I sub x. The trickiest part of the whole problem now is when you go back to the original circuit diagram to be sure that we're labeling the currents that we've identified correctly. Well, the first one is pretty easy. I sub 1 is over here. That's also the least useful. But I sub 2. I sub 2, if I look at the second circuit, the first one that I simplified, I sub 2 flows through the 5 ohm resistor and it flows through the 2 ohm resistor. But in the original circuit diagram, there is no 2 ohm resistor. That was broken down as the parallel combination of two other resistors. But the 5 ohm resistor is still there. So I can still label I2 as flowing through the 5 ohm resistor. You have to be very careful to label the current that you identified in later circuits using the correct landmarks in the original circuit. So I have I2 that's flowing into the node labeled V1. The only thing that I'm left to find is I sub x, and that's a clear application of current division. So I sub x is going to be equal to I sub 2 multiplied by the opposite branch, 3 ohms, divided by 3 ohms plus 6 ohms, and that is going to give me 0.4763 amps. So it was quite a lot of work to solve this problem. Not as much work as the next example is going to be, but we went through 3 additional circuit diagrams. We labeled 2 additional currents, I sub 1 and I sub 2, but as we worked our way back up, we were able to use current division and Ohm's law to identify any voltages or currents that we needed to find in the original circuit diagram. I think you can see how the process goes and how this idea of simplification followed by re-expansion is really valid. And especially when you see a problem worked by hand like this rather than in the notes, you can see that you're going to progress down the page, then you're going to progress back up the page. And I think that's why the different colors of ink or pencil make a difference to help you to break down the problem.